Imagine for a moment that we are traveling not just across our planet, but across the entire solar system, with a particular focus on its most distant and mysterious regions. Now, let's take that one step further and consider a time when our solar system looked very different, when the planets, moons, and the sun were not as neatly arranged as they are now. What if, millions of years ago, an event of unimaginable magnitude, something so extraordinary that it could shape the entire structure of our solar system, took place? This event was no small occurrence. It involved the close approach of an alien star, one that passed through the solar system, disrupting the planets and causing ripple effects that are still being studied today. What might have caused the strange behavior of moons around gas giants like Jupiter and Saturn? Could an encounter with another star explain these bizarre phenomena? Recent studies have uncovered surprising evidence that points to just such a star. And what's even more fascinating is that this distant star may have influenced not only the moons and objects in the outer regions of the solar system but also shaped the entire evolution of our planetary system as we know it. So, buckle up, as we take a journey through time and space, exploring the potential of this wild theory and what it might reveal about the solar system, the universe, and our place within it. To start, let's turn our attention to the Voyager missions, two spacecraft that have been voyaging through the vast emptiness of space for over 4 decades. Launched in 1977, Voyager 1 and Voyager 2 were sent to explore the outer planets of the solar system, and they accomplished their mission brilliantly. But what makes these spacecraft truly unique is that they did not stop after their primary missions were complete. They kept going. Today, Voyager 1 is the farthest human-made object from Earth, currently over 24.6 billion kilometers away from the Sun, and Voyager 2 is just over 20.6 billion kilometers away. They have crossed into interstellar space, an area beyond the influence of our Sun's gravity, and continue to send valuable data back to Earth. These two space probes are now our emissaries, carrying human-made technology farther into the cosmos than ever before. However, even as these probes venture deeper into space, there's an entirely different kind of exploration happening right here at home. Scientists have been revisiting theories about the distant past of our solar system, and one in particular is capturing significant attention. What if a mysterious star, from a nearby region of our galaxy, once came so close to our solar system that it drastically altered its architecture? In fact, recent research suggests that such an event may have occurred, and this star could have played a pivotal role in shaping the solar system's current structure, including the orbits of planets and the behavior of distant moons. The idea that our solar system was once visited by another star is not only intriguing but also groundbreaking, as it forces us to rethink the stability and formation of our cosmic neighborhood. For centuries, astronomers have been studying the solar system's planets and moons, and for much of that time, the origins of certain objects remained a mystery. One particularly perplexing feature of the solar system is the collection of irregular moons orbiting the gas giants like Jupiter, Saturn, Uranus, and Neptune. These moons, unlike the orderly prograde moons that revolve in the same direction as their planet's rotation, follow retrograde orbits, traveling against the rotation of their host planets. These retrograde moons are found in the outer reaches of the gas giants' moon systems, and their highly inclined, eccentric orbits have long puzzled astronomers. It's as if these moons were not part of the planet's original formation, but rather were captured from somewhere else in the solar system. So, where did they come from? Over time, scientists have developed several theories to explain the existence of these strange moons, and one theory that has gained significant traction in recent years is the idea that these moons were not formed in the same way as the more familiar prograde moons. Instead, these retrograde moons might have originated in the outer reaches of the solar system, in a region beyond Neptune known as the Kuiper Belt. The Kuiper Belt is a vast, icy region of space filled with comets, asteroids, and other small objects. It is considered to be the remnants of the early solar system, the building blocks that never coalesced into planets. Many of these objects in the Kuiper Belt travel on elliptical orbits that are inclined at angles to the plane of the solar system. Some scientists believe that these retrograde moons were once part of this distant region and were captured by the gravity of the gas giants, such as Jupiter and Saturn, as they ventured inward toward the Sun. The hypothesis that the retrograde moons originated in the Kuiper belt makes sense given the chaotic nature of the early solar system. The outer solar system, with its many icy bodies and distant objects, was a very different place billions of years ago. Jupiter, in particular, is believed to have played a significant role in shaping the early solar system. Astronomers believe that Jupiter originally formed farther out in the solar system, beyond its current orbit, and slowly migrated inward over millions of years. As Jupiter moved inward, it exerted powerful gravitational forces on the surrounding objects, scattering many of them and causing a kind of cosmic cleanup in the outer reaches of the solar system. This migration of Jupiter, known as the Great Migration, is thought to have played a key role in the formation of the planets we know today, including Earth. However, the migration of Jupiter didn't happen smoothly. Instead, it may have involved a chaotic series of events, with Jupiter slingshotting other objects into the inner solar system and scattering the outer bodies to the farthest reaches of space. While this theory has been successful in explaining the origins of some of the retrograde moons, it doesn't account for all of the peculiarities observed in the current moon systems. This led a group of scientists, led by Suzanne Fair from the Jülich Research Center and collaborators from Leiden University, to explore a new hypothesis. What if the retrograde moons were not the result of Jupiter's migration but instead the consequence of a close encounter with an alien star? This new idea takes into account recent findings that suggest an external force, like a passing star, could have had a profound effect on the orbits of objects in the outer solar system. The new theory suggests that about 4.5 billion years ago, a star with a mass roughly 0.8 times that of our Sun passed near the solar system, at a distance much closer than any of our current spacecraft, including the Voyager probes. In fact, this star may have come as close as 16.5 billion kilometers to the Sun, roughly 110 astronomical units, or about 4 times the distance from Neptune to the Sun. Such a close approach would have caused massive gravitational disturbances in the outer solar system, affecting the orbits of distant objects in the Kuiper belt and beyond. This interaction, the researchers propose, could have flung many objects inward toward the gas giants, where they were captured by the planet's gravity, becoming their irregular moons. The idea that an alien star could have caused such widespread disruptions in the solar system is not as far-fetched as it might initially seem. After all, stars are constantly moving through space, and our Sun is part of a larger stellar neighborhood. In fact, the Milky Way galaxy is filled with stars, some of which pass relatively close to our solar system over the course of billions of years. These encounters, while rare, can have significant effects on the dynamics of the solar system. In this case, the passing star could have acted as a kind of cosmic perturbation, triggering a series of gravitational interactions that reshaped the orbits of distant objects and sent some of them spiraling toward the gas giants. To support this theory, researchers ran computer simulations to model the effects of such a stellar encounter. The results were striking. The simulations showed that the gravitational influence of the passing star could explain many of the peculiarities observed in the orbits of distant objects, such as the dwarf planet Sedna. Sedna, which was discovered in 2003, follows an extremely elongated orbit that takes it far beyond the orbit of Neptune, and its trajectory has long puzzled astronomers. The new model suggests that the star's gravitational pull could have altered Sedna's orbit, sending it on its current, highly eccentric path. The simulations also showed that the passing star could have flung many objects outward, beyond the orbit of Neptune, while also pulling some objects inward, where they could have been captured by the gravity of the gas giants. Interestingly, the model suggests that the chances of an object being captured in a retrograde orbit, moving in the opposite direction of the planet's rotation, was much higher than for prograde moons. This could explain why the retrograde moons are so numerous compared to prograde moons, particularly in the case of Jupiter, which has a disproportionate number of retrograde moons. The implications of this theory go far beyond just the moons of Jupiter and Saturn. If the passing star really did have such a profound impact on the solar system, it could help explain many of the other mysterious features of the outer solar system. For example, the unusual orbits of many trans-Neptunian objects, TNOs, which are icy bodies that lie beyond Neptune, could be the result of this stellar encounter. Many of these TNOs follow highly elliptical orbits that are tilted relative to the plane of the solar system, and their strange trajectories have long been a source of confusion. The theory of the passing star could provide a much-needed explanation for these bizarre orbits, suggesting that the gravitational interactions caused by the star flung these objects into their current paths. What's more, the idea that this star's encounter could have disrupted the protoplanetary disk, the vast cloud of gas and dust that surrounded the young sun during its formation, is equally compelling. The gravitational forces of the passing star could have stripped away much of the material in the outer solar system, reducing the mass of the Kuiper belt to a fraction of its original size. This would explain why the Kuiper belt today contains only a small fraction of the material that should have been present based on models of solar system formation. It also helps explain why the distribution of objects in the Kuiper belt is so uneven, with large objects like Pluto and Eris surrounded by vast regions of relatively empty space. The theory of the passing star is still in its early stages, but the evidence continues to accumulate. With new data from the Voyager spacecraft, as well as future missions to the outer solar system, scientists hope to uncover even more clues that could shed light on this cosmic mystery. The idea that our solar system was shaped by the gravitational influence of a distant star adds a fascinating layer to our understanding of the solar system's history. It suggests that the solar system we know today is not a static, unchanging place, but rather a dynamic and ever-evolving system shaped by a series of cosmic events. As we continue to explore the solar system, we can only imagine what other surprises await us. The Voyager spacecraft, with their decades-long journeys into the unknown, are just the beginning of our exploration of the cosmos. And who knows what we'll discover next? The universe is full of mysteries, and with every new discovery, we move closer to understanding the forces that shaped our solar system and the universe as a whole. The strange and powerful influence of the passing star might just be the key to unlocking even more secrets of our cosmic home. As we look toward the future, we can be sure of one thing: the journey of discovery is just beginning, and the best is yet to come.